So, welcome to using clamp to limit values. In this video, we're going to learn how to make our barrel actually move up and down, and furthermore, make it only move up and down as much as we want it to, so it doesn't either pass through the tank or point bolt upright. So, see you in there. Okay guys, we can finally get this barrel on the move. So firstly, this magic number here about the elevation, I'm going to keep a magic number, but I'm going to start off with it being 1, i.e. 100% of its speed. Then we're going to make sure that it actually does move at about 20 degrees per second. In fact, that's too fast, isn't it? Let's go for a little bit of a lower speed. I'll do that in the tank blueprint because 20 degrees per second, it's only going to take 2 seconds. We're not going to be able to see what's going on. So let's go down to, say, 5 degrees per second for testing. Now, I'm doing this in the blueprint because I want to override the C++ value. I think that 20 degrees per second is perfectly reasonable as a default, but I think that 5 for testing here makes more sense. Okay. So we're going to call this method with a value of 1 in the tank aiming component there, which means 100% of your maximum speed. It's still a magic number, still needs to be tied through to what's coming out of here, but for now let's just use it for testing. So let's go ahead and actually get this tank barrel elevating and making sure that if we pass in a relative speed more than 1 or less than -1, that it still only goes at the maximum speed. So how are we going to do that? Well, let's just get on with it. I'm going to talk about there being an elevation change in this particular frame, and that's going to be how much? Well, it's going to be the relative speed times the max degrees per second. So at this point, we've got a number in degrees per second. But of course, if we have something per second, and this is an elevation change of this frame, that's too long a variable name for me to use, but you get the idea. Everything's this frame in the game, basically. Then we need to go get the world. And then, do you remember the method? What am I looking for the world? What am I doing here? Rather than just watching me. Have a think about it. How am I going to correct this to make sure that it's frame rate independent? Well, it's delta times seconds. And that is a property, so no brackety things. Okay, so that's the elevation change that we need in this frame. Hopefully that makes sense to you. If relative speed was 0, we'd get 0 out here. If it's 1, we'll get max degrees per second, and everything in between. Right, so the next thing is we need to think about what the unclamped new elevation would be. So we can call it, or raw if you like, raw new elevation. And this is saying, well, if we weren't concerned about the fact that there's a maximum and minimum possible elevation, then the calculation would be really simple. It would be simply the relative rotation of the barrel dot pitch. Oh, if I can spell properly. Now, relative rotation is a property here of this scene component. Dot pitch. And if we were just to take that and add the elevation change that we just calculated, whether it be positive or negative, then we would have some new elevation. But imagine that the current pitch of the barrel is 20 degrees and that this elevation change works out more than that. And, well, actually, let's use some real figures. Say what have we got? Max elevation of 40. All right, so imagine that the current barrel is just under 40, but this elevation change would take it above 40. What's going to happen? Well, the barrel's going to exceed its maximum elevation, right? So we need to clamp to make sure that can't happen. Now, before we go on to talk about how to clamp this elevation, let's show the problem. So let's go ahead and set the relative rotation of the barrel, and we're going to give it a new F rotator. And we're going to construct that with the elevation, or the raw new elevation for now, and 0 and 0 for yaw and roll, okay? And close as many brackets as we open. Cool, so hopefully this makes sense. We work out what the elevation change is, we work out what the new elevation would be given the current elevation plus the elevation change. You could put this in an intermediate variable, but I think that's a bit much. And then you pass it straight to the barrel. Let's see if this works. Let's go ahead and compile our code. And then let's see what happens. Hopefully, if the tank, make sure your tank is saved, by the way, and that you've got a max degrees per second in the barrel of, say, 5, so that it moves at a testable speed. Let's have a look. Oh, cool. Look at this. Now watch the barrel. Let's notice when it stops. 6, 7, 8, 9. Okay, so this is why we need to clamp the barrel elevation, right? So it should have stopped after 8 seconds, I think, because we had 40 degrees max elevation, and it's gone all the way to vertical. It doesn't go past vertical, and that's because we've hit the maximum possible rotator pitch value. You can, in principle, pitch further, but this rotator won't pitch any further. And that's fine for the barrel. It's got plenty of range for the barrel. We don't want to even go that high. If you look at the barrel and you look at the parameters, we set a max elevation of 40 and a min of 0. So therefore it had 40 degrees to travel through, 5 degrees per second. It should have taken 8 seconds. It should have stopped at 40 degrees and it didn't. So that is what we need to sort out next. But you've done plenty of watching me write code and not very much writing code without my help. So guess what's coming? It's challenge time. I want you to clamp the elevation. You're going to use a method called fmath : clamp. Now, why is it : A couple of videos ago, I did something with a : That's a static method. Static methods basically are things that are completely functional. It means that this method is going to spit out a return value and not mutate or change anything. So it's pretty easy to use. The IDE will tell you what it takes in and what it returns. And you can also have a look online to see different signatures and different ways of using this. There is a generics format with chevrons, the angle brackets. But take a look online or use the IDE to work out how fmath clamp works, and then test that you have indeed restricted your elevation in between the two parameters we set in the header file, the max and min elevation. Okay, see you in a moment. Okay, so let's clamp this puppy. So auto, I'm just going to call it elevation rather than anything more complicated. I'm going to take elevation off here because we're going to be passing it through. We're going to go fmath : clamp, and it's going to take a few things. Now look at this signature carefully. It's got a generic template here, which means that you can tell it to work on a particular type. So that's what's happening in the angle brackets there. We could tell it the type of thing we want to clamp. Why don't we do that just for fun? I'm going to say let's operate on floats very explicitly. Then the first parameter is going to be the thing that you want to clamp, which is the raw new elevation. The next parameter is the minimum, which is the min elevation degrees, and the other one is the max elevation degrees. Where's that gone? Let's take a look. Max elevation degrees. Well, it's there, so I'm going to ignore IntelliSense because it hasn't caught up, bless it. And I am just going to assume that this is going to work because I think I've used that method properly. You don't have to put the float there, but in doing so, I'm telling it to explicitly work on floats. All right, let's have a go. If you don't do that, you may get some implicit type conversions where something is converted from an int to a float or whatever, and I prefer to be specific about what we're trying to do. Let's have a go. So now when we look at it from the side, I'm hoping that in the console, if you keep your eye on that, when that hits 8 seconds, the barrel will stop moving. I'm also hoping that if we, that if we depossess the tank with F8 now, and then have a look at this tank, and then if we were to inspect it, which we could do through the world outliner, we may be able to get to the actual barrel inside that tank. We're going to need a bit of messing around over here in the details tab. And let's click on barrel. And here you go, rotation 39.999, near as Sumi 40 degrees. So it's worked on the upside. It's very likely to work on the downside, but why don't we just try it anyway? One way you could do that would be to go to your tank viewport, to go ahead and rotate your tank barrel's default position up to, doesn't matter, say 30. And then in your calling method, instead of the tank aiming component saying elevate, it could say depress, i.e. -1. Okay, so we're going to go from 30 degrees downwards to 0. Let's see if that works. Then all we've got to do is remove our magic number and we are golden. We will have a elevation working. So there it goes, down, down, down. I think I said 30 degrees, didn't I? So it should take 6 seconds there and it stops at 0. Perfect. Clamped barrel movement. That's what we like. So I'm just going to put my barrel back. I think a default of 0 looks good. I think that 5 degrees per second actually is probably not far off now. So I'm going to push that default back to the code in the tankbarrel.h because actually 20 was a bad guess. And it's fine to make a bad guess, but once you get better evidence, then come back and fix that default. Max of 40 and a min of 0, I think that's perfectly reasonable. I think it would be nice to get our turret to, say, 45 degrees. Let's check that visually, make sure that doesn't look crazy. Yeah, I think it will look crazy, actually. So I'm going to stick with a 40. And then I'm going to make sure this barrel actually has 0 pitch in the beginning. That's cool. And I actually think that a bit of negative pitch should be possible. But the question is that possible on the back of the tank? And I think it isn't. I think that if this turret was facing the other way, we wouldn't be able to go any lower. I've already moved these barrels down a little bit on the model. No, so it's going to have to be a range of something like 0 to 40, or it just ain't going to make any sense, ain't going to work. Okay, fantastic. So they're the settings after all that discussion, 5 degrees per second, 40 and 0. It's going to compile up that blueprint. Final thing we need to do here is say, well, this is all very well. How about 2 more things? How about if I was to call elevate with a value instead of 1, of, let's say that 5 that we had before. Let's just try that. What should happen is that the 5 will come in as a relative speed. The tank barrel will go relative speed 5, that's fine. It'll come in here, and actually it will go wrong at the moment, because what's going to happen is the relative speed is going to multiply up this degrees per second, and it's going to move 5 times too fast. Let's see it doing that. There you go, far too fast, okay? And if I called that with a, do you want to just see it again to prove it? Should take 8 seconds, it's taking just under 2 seconds. So what we need to do is we need to clamp that relative speed here. Now we can just mutate relative speed at this case if in this case if we want, which means you just change it. So why don't you go ahead and do that? As a little micro challenge, why don't you clamp relative speed to between -1 and +1? Well, go on then. I'm not going to do it till you've tried. Okay, so relative speed equals fmath clamp. I'm going to tell it that I want to work on a float and that it's the relative speed -1 +1. Okay, very explicit. Now, I said that fmath clamp doesn't mutate anything. That's true. It spits out an answer without changing the state of anything. But then if we assign relative speed back over the top of itself like this, so the result of this function call assigned over the top of relative speed, then relative speed here on line 12 is different to what it was when it came into the method. That's cool. I think that we can leave the comments. I think they're not doing any harm. We need to just check now that this works with a relative speed call of 5 in the parameters. It should not move any faster than it originally did now. It should take 8 seconds to fully erect to 40 degrees. Here it goes, looks good. And we've clamped that relative speed. That is fantastic. All right, so the final thing we need to do to get this elevation working is, of course, tie it up in the tank aiming component. We don't want this magic number in here. We just want to know how much to move this barrel by, and that amount is this delta rotator that we worked out a few videos ago, which is the change in elevation that we need this frame, according to the tank aiming component, dot pitch. And we don't really care if that value is above or below 1, because it's going to be clamped inside the tank barrel method. So, or class rather. So let's go ahead and run this now. And what I'm hoping is that just pitch will just work. There's lots of justs in there. Now we're going to have to look at it carefully to see if it is working. If it compiles, it does. Let me go F11 so we can get full screen. Right, so what's happening here? If I point, say, there, is that a reasonable pitch? Forget the yaw, it's not going to work. So I'll aim just in front to save confusion. So it's feasible that it's pointing in the right direction. And then you get to a certain distance and the projectile is not going fast enough to get there, so it doesn't even bother calculating. So you could try this with a different projectile launch velocity just to convince yourself that it's probably working okay. So you can come into the tank. Where do we set this launch speed? If I get a launch speed of 8,000, should be able to hit those far mountains now. So if I now aim up, you see it aiming up. I'll F11 it so you can see a bit better. There you go. It's now aiming up into the distance. It's going to hit that hill. And then you aim above the hill. It no longer gets the solution. It resets to neutral. How about this right-hand hill here? You can see, oops, you can see it being very sensitive now to the height up the hill. So I think it's working. Go off the top of the hill, doesn't solve, and returns to neutral. So I think that elevation is probably working. We'll know for sure when we start doing rotation, and then we start actually spitting out some projectiles and seeing their path, and everything will be much clearer. So hopefully that made sense as to what we've done there. We've sent the pitch in, and then we've processed it in here. And yeah, I'll see you in the next video.